welcome to this explainer. Today, we are diving into a complete A to Z blueprint for something incredibly powerful. We're going to construct your very own military-grade Mobile Ad-hoc Network, or MANET, from scratch using software-defined radio. We'll be unpacking the logic, the software stack, the hardware checklist, and everything else you need to actually pull this off. But first, let's kick things off with a pretty critical question. What happens when fixed communications fail? In a disaster or a hostile environment where every single cell tower goes dark, how do you maintain those high-bandwidth tactical links? How do you keep vital data and video feeds flowing when the traditional infrastructure just vanishes? To answer that, we're taking a journey from foundational network theory straight to the hacker's workbench. Here's the roadmap. First, the MANET Revolution. Second, MANET versus traditional networks. Third, the tactical SDR architecture. Fourth, the hardware build stack. Fifth, mesh routing and software. And finally, deploying your network. Section 1, the MANET Revolution. So the crucial takeaway here is that a MANET requires absolutely zero cell towers and zero satellites. Every single unit on the network is fully self-contained. It acts as both a transceiver and a router. If a building blocks a signal, the network doesn't just drop. It instantly self-heals by bouncing that data through another node. It's completely independent of fixed infrastructure. And I love this analogy because it brilliantly illustrates the concept. Since a MANET operates at OSI layer 2, the data link layer, it gives you a totally transparent plug-and-play network over dynamic RF links. You don't have to stress about reconfiguring IP addresses on the fly. It is literally like unrolling a massive invisible Ethernet cable between you and everyone else on your team. Section 2, MANET versus traditional networks. Now, you might be thinking about standard Wi-Fi or hobbyist mesh setups, right? Well, the contrast is huge. Standard mesh networks rely heavily on a vulnerable master node to assign IP addresses and manage traffic. But in a decentralized MANET, the nodes collectively route the traffic. Without that central master node, there's absolutely no single point of failure. It is infinitely more resilient. Just to give you a sense of how scalable this actually is, a commercial MANET system called the MPU-5 recently ran a flat network of 700 nodes at Fort Carson. 700! They maintained clear voice, HD video, and real-time position tracking across multiple hops, all while vehicles were constantly moving and shifting around. That's the true power of adaptive routing in action. Section 3, the tactical SDR architecture. Let's move to the brains behind this massive capability. To pull this off, we use a combined architecture. Software-defined networking orchestrates the routing up in the control plane, while the software-defined radio, or SDR, dynamically manages the physical layer below. It's an incredible synergy. The network's demands literally instruct the physical radio hardware on how to behave in real time. You see, unlike traditional analog radios that rely on hard-coded physical circuits, an SDR digitizes the signal almost immediately. By replacing those hard-coded analog filters with programmable software, you get instant frequency agility and dynamic waveform updating. You're basically rewriting the physics of the radio through code. It's a real game changer. Now, if you compare a basic hobbyist hacker app to a military-grade MPU-5, the gap in processing power and MIMO capability is just massive. To bridge that gap for a DIY build, you're going to want the Pluto Plus SDR. With its integrated Zynq FPGA and dual-channel MIMO, it gives you that robust foundation you need for high-bandwidth tactical communications. Section 4, the hardware build stack. Okay, let's open the toolbox. Here is your physical build checklist. The Pluto Plus is your core radio engine. Next, you need a brain, a single board computer like a Raspberry Pi or Rock 5B. Then you'll add power amplifiers to boost your multi-watt signal output, low-noise amplifiers to clean up incoming data, and TRS switches to ensure your high-power transmission bursts don't fry your delicate receiving electronics. Hook all the whole shebang up to wideband antennas and your hardware is set. The Pluto Plus really is the absolute anchor of this stack. Why? Because it uses the exact same analog devices transceiver family that you'd find in modern multi-thousand-dollar tactical radios. Plus, that onboard Zynq 7020 chip lets you run incredibly complex digital signal processing right on the silicon itself. Section 5, mesh routing and software. Of course, hardware is nothing without instructions. Let's trace how data actually travels through this system. It starts at the application layer, like your ATAC app, generating data. That data drops down to a protocol like MIMO for layer 2 mesh routing. It then translates through the libio hardware drivers, and finally, bursts out of the Pluto Plus antennas as custom, digitized radio waves. Depending on what you're trying to achieve, you've got a couple of options for the mesh logic. You could choose a routing protocol like BATMAN, which basically acts like a giant virtual network switch at layer 2, ensuring seamless, fast roaming and IP transparency. Or you could use a system like AirDen, which continuously dynamically routes IP traffic at layer 3 and features excellent auto service discovery. Both are fantastic open source options. Sitting at the very top of this software stack is ATAC, the Android Tactical Assault Kit. This is the tactical application that actually puts your new high-bandwidth MANET to work. It allows you to seamlessly sync GPS locations, stream live body cam feeds, and share perimeter drawings across your entire team's devices in real time. It really is the ultimate interface for a tactical edge network. Section 6. Deploying your network.
All right, you have the hardware and the software, so let's talk deployment. You essentially have two options here. First, you can run the routing software directly on board the Pluto Plus itself, turning it into a completely autonomous standalone node. Or you can offload that processing to your Raspberry Pi host. This second method is great because it leaves a lot more processing headroom on the SDR to handle complex, high-bandwidth waveforms.
What makes this deployed node so incredibly powerful is its resilience to electronic warfare. Because you fully control the SDR software, your node has a low probability of intercept and detection. You can instantly hop frequencies or shrink your channel bandwidths to effectively hide your RF signature from anyone trying to monitor your communications. It is a completely adaptable, stealthy system. We've gone from the theoretical physics of decentralized routing straight through the practical hardware and software build stack. You now hold the definitive A to Z blueprint to put this all together. So, the only question left is, how will you deploy this open source tactical capability? What will you build? Thanks so much for joining me on this explainer, and I'll catch you next time.